Morning everyone, thanks for coming here so early. We're going to have a look at some buildinfo files and what we can try to do with them. This relates to the reproducible build project, which created the specification for buildinfo. So we, in the reproducible build project, have been looking for ways to reproduce Debian's packages from source code to binaries. The work in Stretch has focused on removing potential causes of non-reproducibility between two successive builds. And that project went very far, managed to fix problems in 94% of Debian source packages. That's until we start considering additional potential causes of non-reproducibility, like the build path issue. But so far, the testing infrastructure hasn't focused on reproducing the actual binary packages that Debian publishes to its users. So that's kind of what I've been looking into next. The buildinfo file describes the environment in which a .deb binary package was built, or many .debs were built from a single Debian source package. Now this serves as a useful aid in figuring out why a binary didn't match what you expected. This is generated, you may have seen, if you run sbuild, pbuilder, or even dpackage build package, you probably see not only a .changes file, but a .buildinfo file is now generated. That also gets uploaded to the Debian archive if you use debug or whatever else people use. This buildinfo file is describing any potential reasons that your binary package might end up different from when someone else builds it. We are archiving buildinfo files, not just the ones that are created on developers' machines, but each of the official Debian build servers creates a buildinfo file when it finishes building. So we can compare the developer's build environment to the official build machine's build environment and try to understand if there are differences in the binary output, why that might be. And that's a good aid to debugging reproducibility issues. Once we know what the differences are, we can try to avoid those having an effect on the build binary package. Because ideally, we want a package build to always produce the same output so that we can verify that it is trustworthy, not tampered with. Some reasons packages are not reproducible. You've probably heard if you've been to Holger or Chris's talks. All kinds of strange details of specific to the build environment, like the host name of the machine or which user built the package. These are quite often embedded into a package. Causes it to be different when someone else builds it or on a different machine. There are things like time, which is always changing. If that is embedded in the form of timestamps, you will get a different binary output on each build. Randomness can creep into the build. Some file systems order files on disk randomly, and if you read them back, this directory contents, you might get files back in a different order, and that could lead to things being built in a different order or linked in a different order, and so forth. There are other causes of non-reproducibility, which I categorize a little bit differently, like build path, the current working directory when you build the source of the package. That's something that could potentially be fixed by building with the same path that the official Debian packages were built in. And There are other variations, like to these environment variables, deb build options, and deb build profiles. If you change things in there, it is quite often expected that you get a different binary output. So this is why we also want to record the values of these environment variables when we build packages. And of course, if you change the installed build dependencies, like the compiler version used, it's quite often expected that you would get a different binary output. So all of these things are included in the build info. What that leads to then, if we want to reproduce a binary, we simply take the source package and hopefully all the necessary information would be included in the build info. That you take the source code, you follow the instructions given in the build info with the specification given in the build info file, and that's a recipe for producing a reproducible package every time, in theory. The build info looks something like this. I've only included the most relevant fields on this slide, as there are many more. So as I said, the build path is there. The installed build dependencies and their versions, and some details of the environment. And of course here, here we also include the hashes of the output binary packages within this file. The whole thing can then be signed, and then the signature is an attestation that someone was able to build this package, and these are the hashes of the binaries that were produced. So to reproduce official Debian packages, if we have access to the build info file that was produced by the official build servers, the build info file contains the build path that was used. So if the user is able to create the same path in their own build environment, then it should be the same across both builds and not lead to any variation. If you try to reproduce a package in a plain, up-to-date zilch root, it's quite possible that your installed build dependencies will be different from the ones on the official build server, because these are changing continuously in Debian Unstable. So it would be necessary to install additional build dependencies, or even downgrade some to an older version in order to be quite sure that you will get the same output. So my project this week has been writing an automated tool for this second point, to install build dependencies, old versions of build dependencies from, I've been using the snapshot archive, snapshot.debian.org, which has an archive of all old versions of Debian packages that you would need. So I will demonstrate the tool that I wrote. It's written in Perl, because Perl already had available modules for passing the build info file format, and then after passing out the build dependencies, I used the www.mechanize Perl module to connect to the snapshot.debian.org web service, search for specific versions of build dependencies that we need. So that is running now. It's making many queries to snapshot.debian.org. I hope that's okay. I could use a caching web proxy so that if I've run this once before, then it should remember the result. From the result of that, it's constructed an apt sources list with about 120 entries, one for each old version of a package that we might need within the build environment. This is not the most efficient way to do it, but I would say optimize your code last. Now, updating your apt package caches with 120 entries in the list takes some time. Also, each snapshot is a snapshot of the whole archive, so it contains an index of all the packages in the archive, 10 megabytes each. So after downloading, it has to calculate the package index. There will be many duplicates because, for example, if a package exists in an old snapshot and has not been updated, it will still exist in the new snapshot. But my tool is performing a brute force search of every possible apt sources line that it may need to be able to find all the versions of these packages. So now, this is running as a hook within sbuild. It's running apt-get like this, installing all of the build dependencies that would be needed, and specifying the exact version with this equals version syntax. I have to allow downgrades on the command line because we are actually downgrading GCC to an older version if that's what was used to build the official package in the archive. Looking in more detail at this apt sources list, maybe slightly alarming sometimes that sometimes the snapshots are from 2013. That means that the binary package needed to build a new package in SID has not been rebuilt since 2013, sometimes 2011, or even something older. These are packages that were uploaded and never rebuilt in 5+ years. And these are still being used to build new packages. So that could be a problem. So this is still installing build dependencies. Now it's running the actual build. So at this point, the sbuild shroot should be it should be a pretty good replica of the state of the shroot on the build server when this binary package, this is dash, was originally built. So if there are no causes of unnecessary reproducibility in the package, then we should be fairly confident of getting the same binary output at the end of the process. Okay, it's finished building. As I mentioned, sbuild will automatically produce a buildinfo file for you now, so I can compare the buildinfo of the build I have just completed to the original buildinfo. These are all archived on an internal Debian server, so currently only Debian developers have access to that, but we should be able to make this public soon. We're still figuring out the best way to do that. So comparing these two buildinfos, on this line we have checksums for the output dash.deb package, and we can see that it was identical from the official build to my own build that I just executed now. Within the buildinfo, the only difference is here the build date, the actual build date when the .deb was built is recorded here, but that's not recorded inside of the .deb. So the .debs were identical. As a side point, I actually carried out that build with no check so that it would be faster, but that didn't actually have any effect on the binary output. So that may be a way to speed up some of the reproducibility testing, that we just don't run the test suite. If it does lead to differences, we could try running it again with the test suite to see if that does cause it to be reproducible again. So, as a result of writing that tool, because it takes so long, I only ran about 10 packages through this process so far, but 9 out of 10 were reproducible. So I managed to reproduce official Debian.debs from the official archive, and I got the same result when I built them on my own machine. So I'd agree that Debian is probably at least 90% reproducible. I mentioned we have some old binaries still in the archive. These were not necessarily built on official Debian machines, but quite possibly built on the Debian developer's own machine, which is problematic for trustworthiness if a developer did not have a clean build environment or the machine was compromised. That .deb package they produced is still in the archive right now and being used as part of the build process of new packages. So I think we want to push the idea of rebuilding some older packages, especially if it makes them become reproducible. Source-only uploads have been possible for some time. If you don't know what those are or didn't know it was possible, you should look this up on the Debian wiki, how to make a source-only upload, where you upload source to the Debian archive without uploading .debs that you have built yourself, and then that ensures that it will be rebuilt in a fresh environment by the official build machines. If you do build .debs on your own machine and upload those, buildinfo will state this, and it has a PGP signature on it, so we will know who you are. There was one package uploaded, I noticed, and for some reason GCC 4.9 was still in the build environment. This was a package uploaded this year, and GCC 4.9 is long gone. I think that person may have a configuration problem with sbuild shroot. It's maybe not removing old packages, so maybe I should contact that person and see what happened there. I found one package that could not be reproduced, even with the same build dependencies installed. That should be looked into. I think it was only a minor difference in a info documentation file, but we should look into why that happened, especially since the reproducible build tests architecture did not detect a reproducibility problem with that package. I came across some buildinfo files that were incomplete. They missed pre-depends of Python, but these were quite old buildinfo files. Maybe the problem has been fixed already, like the package container. So looking ahead, we would really like to have rebuilders continually rebuilding the Debian official packages. And when those builds are carried out, produce a buildinfo file, sign it, and it could already be submitted to the buildinfo.debian.net tool. We can collect buildinfos there and analyze them. For example, it would be really great for NGOs or states, organizations such as the NIST in the US or the BND in Germany could be reproducing Debian packages, signing the output and contributing that to an archive. Then if you find that a package has a signature from Debian, from multiple third parties, then we're quite sure that the Debian build process itself wasn't tampered with. By looking at these signed buildinfo files, we can try to secure the software supply chain, meaning how the source gets built and then distributed to the user. This probably ties in well with the next talk, where I got some of the ideas for this. Basically, if app has some kind of vulnerability when it's fetching the .deb, there is a possibility at the last moment before installing the .deb that we can use buildinfo signatures as a second way to verify what is this .deb, where did it come from, did someone actually build it, are there signatures from multiple parties to let us know we can trust this .deb before installing it. So if app is compromised or if the archive queuing is compromised, we have this independent way to authenticate that the package was actually built by a trusted machine or trusted third party before we go ahead to install it. So I'm running out of time. I will skip some of these other concepts. Do we have time now for any questions? One question.
Question for Tayo?
Yeah, here at the back.
So Steve Chamberlain, thanks for this talk. So I understand we have some binary rebuilds, but they are all Arch-any packages, right?
Yes.
Yeah. So it feels like we should really extend that. I second that.
Yeah, that's true. The tool that I've written, for example, does not handle Arch all packages. I consider that out of scope for the research I was doing, but still a very important topic. Arch all packages are built once and then reused by many built in future across different architectures even. But that also means we have more interesting ways to QA these packages. We can try to cross-build them from different architectures. An Arch package is not binary code tied to a specific machine architecture, so it should be possible to cross-build it. We could try to build this from an AMD 64 machine, from an ARM 64 machine, even something more exotic like a KFreeBSD machine, and we should, in theory, get the same output for an Arch all package.
Yeah, and in fact we don't really know if these packages still build in SID, right?
Yes, that's also a problem. Sometimes the actual packages only support being built on one specific architecture.
No, not the architecture, the version, I mean. So if there is a binary package from 2013 in the archive that was built in 2013 against whatever, Squeeze maybe or whatever, we don't really know. Have you tried actually taking one of these and rebuilding them against a recent SID?
Yes.
Yes, the official tests.arg.org infrastructure is doing this and finding a lot of problems rebuilding those packages.
Okay.
So maybe that's already being done, and I don't need to look into that. Okay.
Great. I'll have to ask you. We are already almost at the beginning of the next session.
Okay, let's do that.
So shuffle.